Okay, slide number 20, or question number 20. Study of health of teenagers plans to measure the blood cholesterol level of a simple random sample of 13 to 16-year-olds. Researchers report a mean X bar from their sample and estimate the mean cholesterol for this population. Explain to someone who knows no statistic what it means to say that X bar is an unbiased estimator of mu. Well, let's go back to the definition of unbiased estimator. That the center of the distribution of X bars is going to be the same as mu, the same as the parameter that we're going to try to estimate. That by no means is something that if I said to my mother, she would understand that. So let's try it in a little bit more plainer English. If I do this again and again and again, if I do this same study again and again and again, the average of all those averages will be the same as that thing that I'm trying to measure, the average of the entire population. Over many, many trials, the average guess, the average of all the average guesses will be the same as the thing that I'm trying to guess. Okay, this made it worse, didn't I? Okay. Over many, many trials. Are you okay with that part? Every single trial has a guess. It's called the sample average. If I take all those sample averages and find its average, that's a number. Hopefully that number is actually the number of, if I interviewed everyone. Okay? The sample result X bar is an unbiased estimator of a population mean no matter what size SRS the study chooses. Explain to someone who knows no statistics why a large random sample gives a more trustworthy result than a small random sample. Back to the idea. Big idea again. We have bias and we have variability. We don't like either of them. We eliminate bias by doing good sampling technique. Good sampling technique meaning simple random sample. We eliminate variability by having larger sample sizes. So yes, every time we do a sample, we get this new guess. But when we have really large sample sizes, there's very little variation in those guesses. They change very little from sample to sample. So any one of those guesses is going to be hopefully pretty darn close to what the real answer is if we could have interviewed everybody. So one more time on that big idea. Good sampling technique eliminates bias. Good or large sample size reduces variability. Are we okay? Are we as good as we're going to get? Yeah, I wish we could just say we're great on this. No, it doesn't sound sincere. So let's take this recording down.